is we're going to be looking at this concept of resolution, okay? You guys have probably all heard of the word resolution before, pixels, DPI. These are all terms that may be familiar to you. And what I want to do today is kind of discuss what they mean and give you an oversight of what they are. The program that is best suited for looking at resolution, DPI, and PPI is really Photoshop. All right, so this will be your first kind of little introduction to Photoshop. We're not going to be showing you how to use Photoshop per se, just kind of showing you how it can be used for looking at images for their resolution, their DPI or PPI. All right, so the reason this comes for us to start taking a look at it is I'm noticing a lot of you are using or starting to use images in your business cards or other assignments, okay? Those images are generally falling from Google, okay? So if you take a look to the untrained eye, a lot of these images can look very, very similar, all right? You need to become a trained person to take a look at this and understand which image is going to be best suited and best utilized for you to use. Obviously, there's the graphic versus the actual photograph. There's some that contain proprietary information or they have the locked logo on them, so they're very difficult and should not be used. But what we're going to be focusing on is this size of resolution or the PPI, or how many actual pixels are contained in each one of these images. Now, the first thing you need to note, any type of image that is comprised on the electronic level is comprised of pixels, all right, generally speaking. We'll learn about the exception of that a little later in the class. But for the time being, I want you to think that any image that we look at is comprised of pixels. Now, when I mouse over every one of these soccer balls, you see that there's a little number that's being shown, okay? That number that's being shown is telling me the actual dimensions of that soccer ball in pixels. So if I take a look here, this soccer ball and this soccer ball look very similar. But if I look at my top one's telling me it's 300 by 299 pixels. All right. The one below it is telling me it's 1700 by 1700. All right. So there's roughly 5.5 times the amount of data in this image than there is in this image. All right. To the untrained eye, basically if we click on our full-size soccer ball here, view original image, okay, if we take a look at this, just looking at the size of this image versus the size of the image below it, the 17 by 17, okay, you can see the clarity difference. So if I view original image, look at the size difference. One has a lot more data in it. So that's just right off the bat, without even understanding pixels, understanding resolution, you should be able to look at this and say, okay, this one looks a lot more sharper, a lot more clear. There's a lot more data that's actually contained within that image, okay? So that is just to the untrained eye. Now to the trained eyes, we spoke about, one of them has numbers that are much higher than the others. So what you need to start thinking about is each one of these images is comprised of a series of dots or pixels, okay? The word pixel is really an acronym or a shortened element for picture element. That's what it's short for, okay? Each one of these pictures is comprised of thousands, if not millions, of little dots. Those little dots kind of show us and tell us what that image is made of. So as I zoom in here, you can see these little dots on an individual basis. In this picture, we have white dots, gray dots, half and half, you know, kind of where it's like a in-between gray and black. We have a solid black, and we have different tonations of these dots that when we put them all together and stand back and look at them, we get an image. All right, so every image or every photograph is comprised of these picture elements or these pixels. Okay, now, in Photoshop, let's just take this image for the time being. The first one we were talking about that is 300 by 300. I'm going to take this image and I'll drag it to my desktop so that you guys can kind of see what you're used to doing. So I'll take that image, I'll put that on my desktop. All right. Then what I'm going to do is go back to my large image that's 17 by 17. We'll close this one out, get to this one. I'll take that at original size, which is important, and I'll take that to my desktop. And on my desktop now, I have this soccer ball and this soccer ball. Now, right off the bat, if I take a look at these images, okay, here's my size, 300 by 300 basically. If you look at my memory size, this one's 29 kilobytes, so it's fairly small. If I get info on this one's 864 kilobytes. So you can see there's just much more data that's contained within that image. Data is a good thing. The more data we have, generally speaking, the more clarity and the more information that's contained within that image. Okay? Now, what I'm going to do is take both of these images into Photoshop. So I'll drag them into Photoshop. So they'll be open side by side here. All right? And each one of these images I can also take a look at by saying image size. All right? Now, this image is 5 by 5 at 300 dpi, or 300 of a resolution. All right? Now, what does that mean? Generally speaking, computer monitors show an image at 72 to 96 pixels per inch. So on your monitor right here, if you look at the front of your monitor, across the very top line, in every linear inch, in other words, from right here to right here within 1 inch, you take a look up like on the screen, from right here to right here, say that's 1 inch, there should be 72 to 96 little dots within one line. So if you multiply out how many dots comprise or make up these monitors, there's millions. All right? If we go to the printed world works at a much higher resolution. All right? So the electronic world is somewhere around 72 to 96 pixels per inch, or dots per inch. The printed world operates under the notion of 300 dots per inch. All right? So when you print something out of a printer, the printer's doing nothing more than laying a series of these dots. All right? It's not magic. It's simply spraying little dots of color to produce a picture. The printed world works at 300 dots per inch. So anytime we're creating a new document in Photoshop, we're going to be creating it at 300. So if I'm creating just a regular sheet of paper, 8.5 by 11, my resolution needs to be 300 pixels per inch. So I'm going to hit OK, and I'm going to show you where I'm going with this. This is my printed sheet of paper. All right. Here's my first soccer ball. If I take this soccer ball, select all, edit copy, I come over to my 8.5 by 11, which is my sheet of paper, and that 8.5 by 11 is set up at 300 dots per inch, or 300 ppi, the resolution, and I paste my soccer ball in there. That is the largest size that this soccer ball can be printed on an 8.5 by 11 sheet of paper. If we take a look at that, that's pretty large. All right, you'd have no problem making a poster with this. You know, come to Mr. K's soccer game. All right, you know, whatever it might be. Now, if I come back to my other soccer ball, select all, edit copy, and I paste that one in, is it going to come in larger or smaller?
Smaller.
Much smaller. So I'm going to paste that one in, and we see the size difference. That's the largest this one can be printed at 300 dpi. All right. Now, the minute I take that soccer ball and I start transforming that soccer ball, all right, what you'll start to see is that anytime I start stretching that, you're going to start losing data. All right, so if I take this image and I scale this image, we're starting to see that image is becoming very, very pixelated. All right, so a lot of that data that I'm taking and stretching out is becoming pixelated, or I'm starting to be able to see those individual pixels. It lends itself to a very unprofessional result. You know, I know when I look at a brochure or pamphlet that someone's produced and I look at it and see that their images are all pixelated, you can tell that they have not had any training within the graphics world. Okay? So it's not necessarily clarity when we look at resolution, but it has to do with the largest size in which it can be printed, which oftentimes leads to clarity. Okay? A good habit to get into is when you're searching for images over, let's just say, Google. Okay, you have the ability to search for high-res images. All right, so if you're searching right off the bat, you can just mouse over it and it will show you the resolution, and you should only be using high-resolution photos. The other option is you could do the search tool, and we could be looking for only large or larger than images. So if I search for only large images on my drop-down here, it's only going to show me large pictures that have or contain a lot of resolution. So this one's 5,000 by 3,750. So this image, you can imagine, is going to be much larger in nature. All right. You look at the size of this one. This one is quite capable of being used. If I were to take this image, this is going to be the largest one yet. Let's bounce this one back to its original size. Bounce my history back. All right, so there's my two originals. And I go over to my new image, drop that one to the desktop, bring this one into Photoshop, select that, copy that over, and this one should be the largest one yet. All right, you can see right off the bat the size and nature of this one. It's not even fitting onto my page. Okay, we can always throw data and pixels and resolution away. We can never add to it. All right. One last important note before I leave you on this one is just because it looks good on your screen does not mean it's going to print that way. To understand that, you have to understand that your screen is displaying it at what? How many? 72 to 96 dots per inch. When we go to print it, we're printing it at 300. So just because it looks good at 72, that's only a third of what it's going to print at. So you need to make sure that it prints well by using an image that's 300 dots per inch or 300 pixels per inch. To do that, you could bring it into Photoshop and just verify the image size, like I said. All right, so we can go image size. It'll tell me this one is 69 by 52 at 72. If I were to change that to 300, all right, it would tell me the size that would be needed, or I could simply divide these numbers by basically a third, and that would tell me the largest size it could be printed. All right, so that's the quick little intro to pixels, DPI, and PPI. We'll spend much more time on it tomorrow. There will be an assignment that you guys will have to do in laying out different size, different resolution images. All right, but that's the quick introduction to resolution, pixels, and DPI.